Okay, so for our second example, the decomposition of the mineral malachite copper 2 or Cu2 CO3HO2 solid yields copper 2 oxide, carbon dioxide, and water vapor. So what mass of copper 2 oxide is produced from 1 gram of this mineral? So first of all, we write out my equation, then I balance it. So a 1 to 2 to 1 to 1. I have given 1 gram of that. I can figure out the molar mass. I want the number or the amount of copper 2 oxide. I can figure out the molar mass of that. So I need to know the number of moles of my given, and I figure that out by taking the mass and dividing it by the molar mass. So 1 gram divided by 221.13 grams per mole gives me 0.00452 moles. I'm going to now use my mole ratio of 2/1, or wanted over given, to figure out the number of moles of copper 2 oxide that I have. Then I'm going to figure out the mass by taking the number of moles and multiplying it by the molar mass of copper 2 oxide, which will give me 0.7194862 grams. I look in my question, is 3 significant figures, so 0.719 grams. If we compare that to solution stoichiometry, here we need to use our concentration to perform our calculations, which, as we should all know, C equals N over V. So an example here is what volume of 14.8 mole per liter potassium or KOH is needed to react completely with 1.5 liters of 12.9 moles sulfuric acid. Well, I write out my equation. I'm going to get a salt and a water, as always. I need to balance that out. And I have a 2 to 1 to 1 to 2 ratio. I'm given, the amount of sulfuric acid, the volume of 1.5 liters at a concentration of 12.9 moles per liter. So with that information, I can figure out the number of moles of sulfuric acid that I have. Now, I want the volume of potassium hydroxide, and I know the concentration of that is given in the question. So I need to figure out the number of moles of my given, and I take that by doing the concentration times the volume, which gives me 19.35 moles. I'm going to take that information and I'm going to multiply it by my mole ratio of wanted over given, or 2/1 in this case, and that means I have 38.7 moles of potassium hydroxide. So to figure out the volume is the number of moles divided by the concentration. I know my number of moles, I know my concentration. Simple calculation gives me 2.61 liters. Now, we need to always remember, though, our law of combining volumes. So we can use the law of combining volumes when the pressure and temperature conditions are constant for both the reactants and the products. So this, again, is gases, so let's keep that in mind. So considering the following reaction, we know there is a mole ratio of 2 to 1, so the volume ratio between the two are 2 to 1, so if 1 mole of dinitrogen tetraoxide is produced, how many moles of oxygen gas must be consumed? Well, I know the number of moles. I'm going to times that by my mole ratio. That gives me 2 moles of oxygen gas. So if 1 liter of dinitrogen tetraoxide gas is produced, then what volume of oxygen gas must be consumed? Well, I know that I need, in this case, 2 liters, because the law of combining volumes tells me that these two are in relation. And again, 2.5 gives me 5 liters of oxygen gas. And in the next bit, we will talk about gas stoichiometry.